Okay. So let's start with that base length of 10 centimeters. Which is of course 100 millimeters. We have to keep everything in millimeters, so that's what we are. That's what we'll go with. So as far as the width goes, 5 is not enough, I think. It's way too small, so I'll experiment a little bit with that, but if we take 10 for the length, I think half of that is fine for the width, so let's go base width as base length times 0.5 millimeters, of course. Well, this is in millimeters, and everything else will be based off of that, so we don't need to put a don't need to put a value for that. The height, that's way more interesting of a value. I think we should be fine with 2.5. We don't need to have that much at the bottom. Yeah, and what I want to do with the base is that I want to print it in a much more granular fashion as the top part, because the bottom part will have kind of like a spherical inside. So 2.5. Not sure why I'm putting the ruler away. Like I needed it already 3 times. So the base height I'll take as the base length times 0.25. Go with that. So that gives us our base cube. Our length, our width, and height. Yeah, it's very nice. Okay. Of course, what we can do is we can always center it. So let's take a look at the cheat sheet here. I think the cube can be centered right away. Yeah, and that will be a boolean. The reason why I'm centering it is because all the circles and whatnot are going to be centered as well. So I have to center this. I'm going to center the whole thing, including the Z height. You need to be mindful of that. So what I'm going to do is I'm going to actually bring it up. I don't want the Z height to be... I want the Z height to be at 0. Means that we'll bring it up by that much, and this will get our Z height to 0. And we want to hollow out the middle with kind of like a spherical thing. So this is going to be... do we want to do anything special here? I think that's necessary right now. We'll have to do like the top part. The contact for the top part will have to fit this thing. So I think I'm going to have to do the unfortunate thing and actually some math again. My gosh. Or have it elevated a little bit, maybe. That also might be an option. Not saying that it's definitely going to be the option. It might be an option as well. Okay, but what we want to do for sure is Boolean difference. That's going to be our base, and we want to cut out a cube, a sphere out of this. Now this sphere will have to have the same... Basically what we want is we want to squish the sphere into the dimension of... roughly into the dimensions of this. So what we want to do is we want to do... For the diameter we want to do... that. Okay. It's going to be centered, so we have to move it away. But first, we have to scale it. And the scale is going to be... Basically, we want it to be located kind of at the top of this. So I want to translate as well. And X and Y will stay the same because the sphere is built in the middle of the whole thing. So here on 0, 0, 0 we would have the sphere. So we want to push the sphere up the base height. And the scale. Okay. So base cutout ratio. No. Sphere ratio, scale ratio, I guess. Would be. I guess I can have this as a separate variable and then use that. That might be an option. I can define that here, and we can use that later on, and we don't have to do like crazy calculations. Same applies for height. There we go. Okay. Which means that the scaling here will be based on the actual height. And we want twice that. Okay. We want to split. Need to be careful with the math now. Very careful with the math now. Yeah, basically want twice the size, but we are squishing it, so we can squish it and then scale it back up, but that's kind of eh. Or we can always do like height ratio. This is X, Y, Z. So we can always do height ratio times 2, because that's what we want here. And you know, we can always just show that. That would be helpful as well. As far as the width goes, yeah, we can use that ratio straight away. So X we are going to leave alone, and of course we are going to modify these. Hey, Fume Toxic, how are you doing? How is this lovely Saturday treating you? We're going to do that. Let's see how this. I'm going to do syntax error for. Oh, my bad. Support child modules, line 8. There you go. Okay, that's way too small. Okay, like, do that at your own risk, man. Be careful with that. Especially now, you wouldn't want to lose your job. Okay, so we kinda... That's way too small. That's way too small. Oh, not the height, the length. No, why have we... Okay, yeah, that's exactly what I wanted. Of course, as always, I sincerely recommend to put this at the start of every project you do here. So this is basically editing precision. So we get, you know, like fast render turnaround and whatnot. Okay, we have to add another ratio here so that we are not touching the walls, because that's a no-go with any 3D print. And then, of course, 144, that's like... Am I done? Resolution. And this is the 360 is the correction. So obvious problem here is we want to have non-zero walls here. So we want to have like a ratio that's in the middle that would shrink the whole thing just a little bit. For that, we want to do... For that, we want to have another variable, so... ratio, and we are going to apply the same ratio to everything basically here. So we are going to go, like, I don't need that much, we just need a little. We can apply that to the scaling here. There we go. And that just, you know, it uses the same degree of scaling on all sides. So if you want to do something like that, you can play around with it. And it's very flexible, you can even go crazy if you want to do something on the other side. Yeah, that would disappear in the whole box. Yeah, something like that. That actually doesn't look that bad. But yeah, basically everything above 1 would poke out from the bottom, so you would want to refrain yourself between, you know, 0 and 1. Let's go back to 0.9. 0.9. It's decent. And what I want to do once I print it, I want to have like probably like suction cups or something like that at the bottom. Add those, since this will be quite light. But there are other ways how to get around that. If you want to add weight, ballast weight, then what I would suggest to do is have kind of like openings. Like you can see that roughly in this part, I could probably pierce this thing through. And I could add some kind of like metal ballast or something like that. And again, like use some kind of plugs or something like that to actually make it kind of watertight or watertight-ish, because you probably wouldn't want to remove those. So there are ways how to get around that. I'm not going to do, well, depending on how much time we'll have, but I'm not going to play with that a whole lot. Okay. We will have to think about male and female plugs for this thing. I'm not going to do that for right now, but essentially what we want is we have cut out a thing here. We want to continue that sphere on the other side, and we want to cut out from that sphere to have like the other part of this whole thing. So if we would show this sphere, that's essentially this thing. Obviously, this sphere... Oh my gosh, I will have to do geometry again. I don't like geometry, man. Obviously, this sphere doesn't really match what we want to do, because we want to have like some kind of a more flat surface, I guess. So we would have to do something else. So what we are going to do... We'll see how well that sits here, but basically I'm just going to play around with the sphere here. So I'm going to take this sphere. This is basically what we have there. If you want to just hide it, you can always see, you know, what we're working with. And we want to pull that sphere out a lot. And I guess in all directions, really. So what I want to do is, again, probably we'll do a ratio here. Blow it out of the water as our first try. So that's the base. Let's call this top. Top ratio, we'll go with 4 just to try. And I always suggest to go like double or half the ratios. So, you know, like quarter, half, 1, 2, 4, 8, so forth. And we'll see how this goes. So, what we want to do is we want to do this. And we need to keep the base cutout ratio in as well, because that's important. We want to fit the whole thing within that base cutout, if possible at all. And okay, top ratio there, and here. Okay, that's obviously a fair bit larger sphere than what we had before. So we have to, oh my gosh. We have to move it. I have to think about this. So half of the it's a bit. We have to keep the base height. We have to keep the base height because that would be like one part of it. Second part of it would be this thing. Well, this thing modified by this thing. Half of that. Just I don't know. I'll come up with a better name. For right now, I'll call it random Z offset. That's not important right now. So we want that times this times half. This will make sense, I promise. Okay. There we go. So that's probably a little bit too much. Wonder whether this would... No. We have to have that here, of course. Yeah, because this is just touching. If you can see directly here, this is just touching it. And here we would have Detroit coming in with the Badlands Musketeer. Here is the bit where I would have to do some math. So actually, from the perspective of how we want to cut this in the end, the length is okay. So like, or yeah, the length is okay. Want to push the height as well, since we are going to have a second sphere that's going to be removed from this sphere, and then it's going to be cut from all sides, and that's the resulting shape we want to do. So essentially what we want to do is we want to have a cutting plane that's made of so probably left the whole thing centered at the bottom. Okay, so what we want to do here, we want to do twice the width, which would be this. Yeah, okay, this is way better. This is way better, but of course we still have to think about that bit down there. Like honestly, at this point we can do just something dirty like that. And you can always do intersection to see whether how well these parts fit. So I'm going to do a module for this. There's some locomotion in the other room. Toggles will come down, though. Okay, so we're gonna do that. And of course, if you are doing modules, that's not a printable entity, so you want to call the module right away. And the other thing is the top bit. So okay, so what we're going to do is we'll have that here. And now we can do an intersection thing. It's called intersection. Okay, so we have these two things now. We have the holder base and the holder top. And what we want to see is we want to get as close of a fit section, the building operation we're looking for. There we go. There we go. And we have no intersection so far. Okay, we have some here, so we want to be above that. Exactly, one was exactly right, I think. Well, not the best fit in the world. And again, there would be some math needed at this point, which I'm not going to do. Like, I'm just going to do to have like a dirty Z offset for the top. I'm just going to put that here. That's real what we are doing here. There we go. So we are going to cut into this sphere, I guess. It's no longer a sphere, but this round-shaped object. Okay, and we are going to do it by... Oh, I guess we can leave it up here. We are going to have essentially a second base. You know what? No. I'm going to hollow it out. This is the way we are going to roll here. So we need... It's not going to be the random Z offset, this is going to be the holder top Z offset. I guess is okay. There we go. Going to be okay. And what we need right now is we need an offset for the inner bit that's going to be pulled out of it, and then the rest would be just cut out. So we need a ratio. It's going to be something very, like, we don't want a very thick wall, so 0.98, 0.95, we'll see. And basically what we want to do is we want to do this object twice, where the second one is going to have a ratio applied to it. Just realized that probably we could do the, yeah. Could have done this. So basically the top ratio is the same for all axes, so that's why we could have it here, and we wouldn't need the top ratio on this side. There we go. So same would apply here. Make the calculation a bit more forgiving. There we go. So do just this. Okay, that works. That's exactly what I wanted to see. And we want a difference. We want difference between this and the small one in the middle, smaller one in the middle. So that and that would be moved. That is the top ratio, cutout ratio. Okay. So we wouldn't see anything here, but if we would go in, oh my gosh, okay. If we would go in, which I can't do apparently. Okay, I'm going to cut this. Have an easier view of the whole situation. So that's that inner sphere, or you know, whatever this is now cut out from the outer one, which would provide us a shell. Now we need to cut it. So we need to essentially go use this offset and plop a larger cube. Or you know what, like we can probably do like a cube that's very large and subtract the middle cube. That's one option. Or we can just do like yeah, various ways how to cut this or skin this cat. Let's just go with we need the ratios to be intact for this. So the top ratio is really what dictates this. So we are going that much above. So we need like a larger cube that is going to be the cutting one. So what we want to do is we want the cutting cube ratio is going to be that times 2, because, you know, times 2 or divided by 2 is the way I want to roll with these. Okay. So that would mean that we have a cube here. That needs to be centered, of course. There. Right, so we need to do that, times that. We need to do width. Times that. Yeah, I did ratio on again. It's just the ratio, man. Don't do the ratio on. And height. There you go. I wanted it all at once, and now this is going to be a struggle. So this should be large. Yeah, exactly. This should be larger than what we have here. What we see is that this is not offset yet, so we need to move this. And the movement is again going to be Z based. And what we moved basically this. That's the amount we have to move it here as well. What did we do? Oh yeah, my bad. My bad. There you go. So now that upper bit is fully hidden, exactly what we wanted to do. And now we want to do the cutting cube in the middle. That's going to be more challenging. So you want to hide this. So basically what we are going to define now is how much we want to keep from this. And this is not going to be much. So basically what we want to keep from this is, I would say, half of this, height-wise. Well, we'll play around with the height, I guess. I'll leave the height to the last bit. Huh. I think about it. It's probably it should be based probably same ratio as well again. Yeah, now that I think about it, probably this whole thing could have been more of a sphere, I guess. Anyway. Let's go down here. So we want to go probably like half of the width and length. Or do you want to do a square around it? Probably a square around it would be good as well. Yeah, let's do that. Let's do that. So what we're going to do is we're going to have like the inner cutting cube. Set going to be that times, let's go 0.25, so we are dividing by 4 essentially, which would mean that the length would be the base length plus this times 2. Remember, this will be centered. We're going to use the width, of course. And for the height, we're going to use something else. We want to probably go fairly low. For right now, I'm going to use the height times f. Okay, yeah. Let's create that. Let's create that cube. Don't forget to, oh no, width, but height. Forget to center this. There we go. So we want to cut out that from that whole sphere, essentially, and this would be the bottom floor of it. So what we want to do is we want to remove this bit from that huge cube. Of course, we need to translate it to the same floor. Yeah. And this essentially would bring the whole thing. Oh, that's way too high because we don't need to move. That's the problem. Without that, okay, we are hiding this, and that's centered. No, this is fine. What we want to do, because this gives us the same centering plane for that, we want to bring it to the floor of this. So what we want to do is we want to use the height of this. So cutting cube ratio that, and we want to move. Basically want to do that. And so 5. Completely makes sense. Don't you worry about a thing, right? Where is my cube? Where is my cube? Where is my cutting cube? There it is. Okay, yeah, we can see that this is not entirely okay, and the reason for that is that we are centered on that smaller cube as well, so we need to push it up. So basically we need to do that plus this, and this will be exactly at the bottom. Oh. Yeah, thinking here because that doesn't seem right. Yeah, I'm probably way overthinking this at the moment. PhD, even Horst plays an epic barbarian on the battlefield. Appreciate it. Yeah, I don't need to worry about the positioning of that one. I think that's the problem I'm having right now. So let's just focus on the holder. Yeah, and the problem I'm doing, or what I'm doing wrong right now, is to actually including the offsets where I would have to move the whole top object. That's not important right now from the perspective of other objects here down below. So I'm going to do, don't make the same mistake at home. So basically this object, or positioning of this object to this place where it is the thing that you want to do at the end of the whole thing, not where I'm at right now. Yeah, it's not what you want to do. So what you need to do is this translation that we have here, and needs to happen outside of this whole thing. So translation, I will put it away here. This will move the whole object to the middle. There we go. Which is fine. It's what we want to do. And the same thing with the cutting. Because now this cube, there we go. Oh, that cube is way too large. I guess I want it to be way too large, so it's fine, I guess. Yeah, and you can see that this is now centered. So what I need to do is, yeah, and the cutting cube must be way larger. That's fine. But I need to forget about the cutting cube because the cutting cube is just the overall object. So what I need to focus here and with this object is how this is positioned in relation to this object. That's really the only thing I need to be mindful about. And that's really, you know, like to put it at the bottom where we actually want to cut out the thing that we want to cut out. So if we take all of this out, to put this whole thing nicely into the center, right? So we need to move it to the bottom of that sphere. So to do that, we need to bring it up a little. Times 5. That centers it at zeros, and now we need to bring it all the way down. So we need to take half of. So basically, we need to take the base 1 stop ratio. There we go. This is basically a top diameter. The diameter should be that. Really? Goes here. And we can use that. Simplify the calculation just a little bit. There we go. Okay, that's fine. And we need to push it down because we have actually squished this a little bit. So the offset is going to be different. Because the base height ratio is 0.25 times 2. Base cutout ratio is the base cutout ratio. Why do I have it there twice? Oh yeah, I know. What I'm doing with that. Okay, that's fine. So we need to modify it by that amount, really. Oh my gosh, this is getting complicated. Okay, so that's the diameter, which means that the inner cutting cube, the offset will have to be at the top diameter times everything we used to scale it with, that, times half, and we need to add the negative sign to that, and we need to add that here. There we go. Okay, so this should be at the floor of that sphere now, which is that. There we go. Is that the bottom? Oh yeah, that's at the bottom. That's at the bottom. We'll see. Oh yeah. So we are roughly at what? Like one notch above that? Yep. We're exactly at where we want to be. So, what we want to do right now is we want to... This is the inner cutting cube. This is the cutting cube. So we want to remove the cutting cube. There we go. Difference. So we want to remove this cutting cube. This is the base in this instance. We want to remove the inner cutting cube. There we go. Which would give us the thing that we want to remove from we want to cut the whole sphere with that. So we'll do this as we'll define this as cutting cube. Yeah, I guess we can do that, and that. It's fine. And what we want to do right now is we want to remove from the top. We want to do difference. And we want to do the cutting cube. There we go. Now. Okay. This is what we wanted. And now we can position the whole thing. So we can do the translation of this whole thing. So if we do that should bring it up. There we go. Okay. So next step is to create some kind that like male-female kind of like standoff kind of thing. And how we are going to do this is basically it's enough to just intersect these two. We don't need to have like precise contact. Even if we increase the fidelity of the cuts to semi-done, we have like kind of like a better idea of how this is going to look. You see, like there is a difference there. This is perfectly fine. We are not going to like perfect airtight like contact there. That's not what the objective is. We just want to have like a larger top part from which we are going to cut like 3 holes so that the water can go down basically, or we can even do just one in the middle. That would be also perfectly fine. For right now, this is enough. There we go. So we want to cut out even 1 hole would be enough here. Yeah, that could be probably enough as well. In the middle, like half of the... We can do like something more fancy, but I think a cylinder is going to suffice here. Don't need to be too fancy here. So, what we want to do... Yeah, the Z offset is kind of the killer here, so... On the Z offset, yeah, inner cutting cube Z offset is we have to think about, or just do like a large enough cylinder that it would cut through the whole thing. And I think cylinder has the z-axis or the centering as well. Let's take a quick look. Yeah, it has centering as well, so we'll do just that. Since this whole thing is going to go to the middle, I think if we scale the cylinder so we kind of do like an O kind of shape, that's going to work the best here. Okay. Now, how do we want to do this? Since we are already removing the cutting cube there, I think if we add to the cutting cube, that's going to be enough there. So essentially, we have the mill ready! Essentially, from this thing that has the... there should be a view, wireframe view, I think. The wireframe, yeah. Has that middle bit. Oh, that's very nice, actually. So where were we? Okay. We have the base, we have the cutting thing, so I'm going to do the top Z offset. Hopefully I didn't use that one. Yeah, I used that one already. Overall top Z offset. Terrible variable names. I know. So we'll have that, but we'll have also a non-translated thing. Beg your pardon. So let's do Z offset. Offset, I told you. There we go. There we go. So that's basically what we are looking at. So what we want to cut out the middle part here. I want to go. So we can do it like two ways, either squash it or either squash the cylinder or pull it out. Or just pick one. And add it to the base cube here, base cutting cube. And that would be... I guess I need to add it to... Yeah, to the whole thing, so that's fine. That's fine, and we'll center it, so that's perfectly fine. Okay, we'll use the cutting cube... cutting cube ratio, so yeah, this is the cutting cube. Okay, we are going to use that same height. We want to have a cylinder added to this thing. So basically we are doing a union here on the difference. And yes, my head hurts a little bit as well. So the age would be... Where is my cylinder? H is the height here. For the height, we are going to use this thing. We want to center it for sure. We want to center it for the diameter. Or we want to use half of the width. There we go. There. So this would create us. It will squash that on the side. Yeah, so we want to scale it. So the length is X. So we want to leave that alone. We want to squash it on the... No, we want to actually squash it on the line. The width we are fine because we use that, and Z is fine as well. So if we add that, there we go. Have that hole in the middle. Huh. Interesting. That's kind of smallish, I guess. Will that be enough? With the hard edge as well? Might be enough, honestly. We can probably do 3 more like this. The sides. And we can have the interface... Or maybe do a larger... Interesting. I mean, if we do this a bit larger, we'll have a larger hole as well. But this might be large enough where the soap might actually fall through. Although I think that we are still good here. I think this works well enough. Maybe we can do 2 smaller to the side of that thing. I'll experiment with that, I think, off screen, but for the time being, we'll keep this. I'm kind of tempted to do it right now. Sure, what the heck. Very. That to the side, and we'll use that as this. And there. We'll have one to the right and one to the left. That, and we are going to translate. By what amount? So basically we want to translate to both sides by the same amount. So we want to take the, and it will be centered, remember. So we can take that and use that as the offset on the x-axis. We want to do that. And we want to do the -1 on the other side. And 3 holes, look at that. That's way too much though. I would want them to be closer, so... Want them to be closer. Yeah, so basically this whole size. Let's use the auxiliary. Offset instead of that one. Oh yeah, now we're cooking with gas. Okay. This actually looks kind of okay. What do you think? I mean, not a world beater by any means, but looks actually kind of okay. We take a look at 144. Okay. And now the most important thing is the actual interface. So we need to have 2 points. 2 points either on the side or somewhere in the middle. So where do we have a good interface for this? Like, we can always go here and just basically cut it in half. That would be an option. Because essentially what we are looking for is we want to do 2 cylinders. Where one would be a little bit smaller than the other one. but they would occupy the same space, so it doesn't really matter where we put the cylinders at all. Of course, the best place is to do the corners. That's the most stable one, so I'm going to do the corners now. So I'm going to hide this. So we want a cylinder that sticks out a little bit, and of course I'm going to change to the editing resolution now, since we're back to editing. There we go. So on cylinders that would stick out, don't need to go crazy. We just want them to go into that. That's not too thick now, is it? Don't. Of course, I have to wing this. How thick is that shell? I know how thick it is. I know how thick it is precisely because we use coefficient there, ratio. So basically that much of the diameter is what we are looking at. Oh my gosh. Okay, so yeah, that's this much. So basically the difference between when everything with this is applied and everything with this is applied, subtracted from each other, that's basically the thickness of the shell we are looking at. So that's the maximum value, and we can work with that actually, because we need to only stick it out. We can take the height of the base, add the thickness, because the shell is just above it, at the thickness there. I think that will work nicely. So let's take that. Okay. Let's call it studs, I guess, are fine. So studs height is the most important thing here. So we're looking at that thing. This whole thing. Times and the ratio. So essentially the top cutout shell is that would bring us what, 5/10, right? 5/10 of the entire diameter. So we'll use that here. There we go. There we go. So that's going to be... oh, that's a ratio. That's not the final ratio, I would say. There we go. So top cutout shell is whole thing, and we are going to add that to the base height. Yeah, that gives us the H value that we are going to use, and now we just need to position these studs appropriately. How much? Let's think about the thickness of these. Stud. Let's go stud height. Stud. Let's go male diameter. We don't want to go too big here. Top. No. Wrong. Oh. Bad. My bad, my bad, my bad. Bad. Probably like 10th of the line should be fine. That's even way too much. 5th of line? 5th of line should be fine. It's 5 millimeters. Yeah, 5 millimeters should be plenty. And we'll do the female bit just a bit larger, like by probably 10% should suffice. 10 or 20%, we'll see. I'll start with 10% and we'll see how that works. So we'll do length. What the F? Oh, Numlock is turned off for some reason. I was like, what's going on here? There we go, so like 5% of that. And the female diameter is going to be male times 10%. 10% should be enough, I think. Yeah, 10% should be enough. Okay, once again. Going to check whether we are still live. Okay, looks that we are still live. That's cool. Okay. Now, positioning of those. So we want to go like 1.5 times what we are doing percentage-wise. So if we are doing 5% here, we want to do 7.5% of positioning of these studs from the base. So stud male diameter ratio is going to be that. And then of course stud offset, since we are going to have these centered again. We don't have to think about the z-axis, we have to think about only on x and y planes. So stud offset. So from the boundary, so what we are going to do is we are going to offset it to the corners and then move it back. From corner is going to be this times 1.5, so 7.5 millimeters in this instance. Let's create that. So we have a cylinder. Wondering whether that should be part of the base. I think it might be part of the base. It'll be easier to calculate as well. So we want to move all of that. Can we move it to the top? Oh, that's the question. I think we have to move the base calculations down. Good thing is about modules that you can move them down, like as long as you have all the definitions at the top, you can move the whole module down, so it's fine. So let's take that cylinder. There we go. Cylinder goes here. That's the first one. So what we want to do is the height that. We have the male diameter. That. We want to center that sucker. We want to translate. So on the z-axis, we want to move half of the height, of course. There we go. That should put it in the middle. Yes, exactly. And now we have to position it here to the corner and move it back. So, in the first one, we want to move it by half of the length. And half of the width. This will bring us to the corner. There we go. So we hit the corner, and now we have to move the stud back. And this is the variable here. So as we move that way, both negative, we have to move back. So we want to use that offset from the corner. There we go. One side and back. Okay. Offset from corner is based on the diameter, not the diameter ratio, of course. There we go. That's the first stud. Now we'll do this 4 times. And play around with the variable. So there, 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 and there, and okay, of course positive we don't need. Positive and positive, which means that negative and negative. There we go. We have the 4 studs ready to roll. So if we unhide the top, we should have contact now. Oh, it's way too much, way too much. Interesting that we went over there. I think I had the calculation down for the shell, but it doesn't appear to be so. So what's wrong is the calculation. Of the top cutout shell for sure. Let's check the calculation. Go back here. So we're looking at the sphere scaled on the z-scale is important here, not the rest of the scales, since that defines the thickness of the shell. Doesn't define the thickness of the shell globally though, so that might be a mistake on my side. Let's do just something dirty here. Do these things dirty. And we'll refine if that's something. I did the render. That's something that needs to be done before I actually post it online. Okay, yeah, this is much better. So you can see the studs here. What we want to do is that's the positive bit. And we want to cut these and have like a photo negative. So what I want to do with the studs is actually use the half of the height of the base and move them that much up. Yeah, so I want from the height, there we go. I want to do that. And of course, when we are moving these, I don't want to move them up that bit. Oh my gosh, this is going to be crazy. So the original bit was... So I want to move them up base height times half plus... Gosh, head's going to pop from these calculations. Okay, stud height, that's fine, and we are going to add that. That will be in... fingers crossed. I did not mess up the calculation in my head, this should be enough. There we go, there we go. That's a nice stud, okay. So we want to do... So these are the males, we want to do the females in the same manner. But the only thing that's going to be different is we are not going to use the male here, but we are going to use the female diameter. And we are going to add all those nice studs to the... Oh my gosh, that's going to be a problem. Is it going to be a problem? Interesting, because essentially I want that to not be the part of the base, I want that to be part of the top. Interesting. So I want that to be part of essentially that. Oh, this is so dirty. Dirty. So if I do that, these are still here. We want to do the female version now on the other side. So we want actually a difference of these. So we want to do actually just this. And we don't want to do a union, we want to do actually a difference. So if I add these back here, this is crazy. And change the males to females. There we go. We have the holes on the other side. And this is essentially it. So we have the larger holes if we... That's the base, and this is the whole thing all together. So you should have a bit of a hole there. We can see that there is a bit of a hole. Maybe we can increase the diameter. So maybe we can do 1.15 to have like a smoother bit there. But if we do just wireframe, surfaces. So if we do, how to best show this? You can clearly see in this one that it goes deep. Okay, I'm quite happy with this. I think this should be enough, because like if we remove that, like we have the male versions here. So, I'm going to check who's online, because I'm pretty much done with this. I'm going to set up the printer and I'm going to print this. We'll see how it works out, and if it looks good, then I'm going to post it again on Thingiverse and leave you a link next time we'll be live. So this is our top and bottom of the so polar that we did on stream just now.